So this is a video lesson on factoring trinomials by grouping. We're going to show you by grouping because that's what we talked about last class, but also I'm going to show you a different method called a box method. Again, same process but a different look on it, which helps students sometimes visualize the terms a little bit better. The first thing we always do with trinomials is understand that I have a 3, tri means 3, a 3-term polynomial, and I'm going to take that and I'm going to factor it. Always look for GCF first, because if A, B, and C share a common factor, I want to factor that out to make my problem a little bit easier. If there is no common term, like our example here, 40, 13, and 1 don't have any common factors, then I'm going to either factor by grouping or use the box method. Either way, what you want to do first is draw a little x here, and you want to go ahead and look at what would A, which is 1, B, which is negative 13, and C, which is 40. What would A times C be? 1 times 40 would be 40. And when I look at B, I get a negative 13. So I need to think about to myself, and this is the question you have to ask yourself, what two factors multiply to 40, but those same two factors add up to a negative 13? And since B is negative and the product of AC is positive, I know that the two numbers both have to be negative. Because negative times negative is positive, and negative plus negative is also negative. So let's go ahead now and figure out our factors of 40. So I have 40 and 1, I have 20 and 2, I have 10 and 4. I'm getting closer to my goal because as I progress here, I'm thinking in my head, 40 plus 1, well that's 41, too big. 20 plus 2 is 22, a little closer. 10 plus 4 is 14, really close. Let's look at our next set of factors. Yep, 8 and 5. Those two add to a 13. So they multiply to 40 and they add to 13, so I know that my factors have to be negative 8 and negative 5. So last class we talked about factoring by grouping, and what these factors are my new linear terms, negative 13x. I can say that negative 13x is really a negative 8x minus a 5x, and that can be the same thing. Now when we factor by grouping, we cut it in half, we look for a GCF in the front, we look for a GCF in the back, and we factor those out. So I factor out an x, and I'm left with an x minus 8. I factor out a negative 5, and I'm left with an x minus 8, and that's promising because my parentheses are the same. And since both these parentheses are x minus 8, that's one of my factors, and my other factor would be the remaining piece, x minus 5. So that's factoring by grouping, and again, looking at trinomials. We're also going to look at this box method, which I think is going to be really helpful for some students, and I'm going to show you that in example 1. At any time throughout the video, if you ever feel like you're getting the hang of this and you want to try it on your own, pause the video and go ahead and try the problems on your own. So we're still going to go through that first step the same, regardless of our method, but we're going to look at the box method for this example. So I'm going to go ahead and first draw my x, and I'm going to take the product of A, which is 1, B is negative 2, and C is negative 63. So we're going to take the product of 1 and negative 63, which is negative 63. B is a negative 2. Now since my A times C term is negative, that tells me that one factor has to be positive and the other factor has to be negative. Now how do I know which is which? Well, since my sum is negative, I know that the bigger factor has to be negative. That's the only way for two numbers to end up being negative is if the bigger number is negative. So when I think about my products for 63, or my factors of 63, one that pops off to mind, since 6 and 3 add to 9, I know that 9 times 7 is a possible combination of 63. And I'm going to stop right there, because when I look at 9 and 7, if 9 is negative, and 7 is positive, that's going to give me a sum that is negative 2. Negative 9 plus 7 is negative 2. So those are my factors that I'm going to use. Now, in our last problem, we did this. We took m squared, then we rewrote this as negative 9m plus 7m minus 63. I'm going to change the way this looks using a box method, and all that's going to do is going to take these four terms and it's going to put them in a box. So I'm going to draw a square. I'm going to draw two intersecting lines, which makes 4 and 4 squares. And I'm going to put the terms in this following order. M squared is going to go in the top left. Negative 9m is going to go below that. Diagonal from that is my 7m. And the bottom there is a negative 63. The order of those terms is very important. So make sure that you're following that same pattern every time. And now what we're going to do is we're going to basically find GCFs, but we're going to move in different directions. So the first thing I'm going to do is look at the first row here. I'll look at this purple box. And when I look at these two boxes, what is the common factor that those two terms share? M squared and 7m share a m factor. So I'm going to write that out to the side. Now let's go ahead and look at the bottom. Let's look at the bottom pair of numbers, the second row. And then the second row, negative 9m minus 63. What do those two numbers or terms have in common? They both share a, let's say, negative 9. Now, since this lead term is negative, I'm going to take out the negative out in front there. Okay, so whatever's closest to where I'm writing my number, if that's negative, let's write a negative. Now let's look at two other possible combinations. We looked at the rows, but now let's look at the columns. I'm going to look up and down. What do m squared and negative 9m have in common? Well, since m squared is positive, the term that I have in common is a positive m. Then I'm going to look at the first column. Now I'm going to look at the second column here. When I look at 7m and negative 63, what factor do I have in common here? Well, the factor that I have in common, or that I'm going to take out, is going to be a positive 7. Since 7m is positive, I'm going to take out a positive 7. So when I look at my factors now, what's written down here on the, I guess, y-axis, and what's written on the x-axis are going to be my two factors of my problem. M minus 9 times the quantity m plus 7. And this is the box method. I really think it's a great way to revisualize your problem. It also gets the same result, just a different way. So if you like this method more than you like the grouping method, you could go ahead and do it that way as well. We want to look at number 2 together because it is a little bit different than what we've seen before. Both examples that we've done before, the a value has been 1. But here, we're going to be looking at a polynomial or trinomial specifically where a is actually now a positive 12. Now I always want to remember to check for GCF, but 12, 11, and 2 don't have any common factors that I could factor out. So because a is a 12, it's really important that when we draw this x, we go ahead and multiply a times c. 12 times 2 is 24. Positive, because they're both positive. B is a negative 11. So since AC product is positive, I know that the signs have to be the same for my factors. And since this is negative, I know they both have to be negative. So I need to think of two numbers that multiply to 24, but add up to 11. Obviously we know there's 12 and 2, and 1 and 24. But when I look at their sums, neither of them add to 11. So we got to look at some other numbers that you could use. Does 3 and 8 work? Yeah, how about 6 and 4? That's true. But when I look at their sums, the only two that add up to 11 is 8 and 3. So I'm going to put 8 and 3 there as my two factors. So at this point you can choose your method. You can do factoring by grouping. You could also do the box method. So the one is 12d squared minus 3d minus 8d plus 2. So if you want to do factoring by grouping, you can do that. Or if you like the box method, you can do that as well. Remembering here in this case, we're going to factor out a 3d. That's going to leave me with a 4d minus 1. And here I'll most likely factor out a negative 2, which will then give me a 4d minus 1. Now if you do your box method, you kind of get to the same numbers and same process. You're just going to look at your vertical pair first. You're going to take out a 3d. Then we're going to look at our other vertical pair, which is negative 8d and 2. Vertically here I can get a common factor of negative 2. And then I can also look horizontally. Here I could factor out a 12d squared and negative 8d. That would be a positive 4d, because 12d squared is positive. And then also negative 3. I'll look at my last possible combination here. Negative 3d and 2. Well, 3 and 2 don't share a common factor. There's only one d in both, so actually I'm going to just take out, since there's a negative here, I'm going to take out a negative 1, because there's no other common factors that I can take out. And 3d is negative, so I'm going to take the negative out. So now, when I factor with grouping, obviously I'm going to take out my common factor, 4d minus 1, and what's left over is a 3d minus 2. Or if I do it by my box method, my factors are kind of listed out here on the sides. I have a 4d minus 1 multiplied with a 3d minus 2. So you can see the advantages to both methods. You can really choose whatever one you would like to do, but make sure that you're consistent and you follow the steps exactly that way. Okay? So here are two for you to try on your own. Go ahead and try those two, and if you have any want to check the key, there will be a key posted on Google Classroom for you to check. So there's your little mini lesson on factoring trinomials.